Today I'm going to introduce you to the concept of buoyancy. Now, buoyancy is something to consider whenever an object is submerged or partially submerged in a fluid, such as when you're designing a submarine or a boat or anything of the sorts. Now, to give me a little help to explain this concept to you, draw a little boat here. It's a beautiful boat, I know. I'm a wonderful artist. Thank you for noticing. And buoyancy itself is defined as the force exerted by a fluid onto an object in such way that it counteracts the weight of a set object, in this case our boat, so weight of the object. And Archimedes' principle tells us that the buoyancy force is equal to the weight of the fluid that is displaced, in this case water. Now if we were to draw our water line right here, it's the amount of water that is displaced in this area down here, or this volume down here. That's how much buoyancy force will be exerted onto this boat. Now this principle doesn't take into account surface tension or any of those phenomenons, but it's a pretty simple and fairly accurate way to determine how things, or if something will float, or what kind of forces are being enacted onto it. Now, in this scenario here, let's say that our boat weighs about 100 newtons. We would place the boat in the water, it would start sinking until it's displaced exactly 100 newtons of water, at which point our buoyancy force is going to be equal to 100 newtons, creating a system of static equilibrium where the net force is equal to 0 if we do our force equation here. So we'd have our buoyancy force working upwards minus the weight of our object, and that equal to 0. 100 minus 100 equals 0, and this just confirms that this boat is going to float. Now what happens if our buoyancy force is less than the weight of our object? Well, the answer is simple. The thing's going to sink. And in some cases, that's great. Other cases, not so great. Submarines want to be underwater. They don't want to be on top of water all the time. But a boat wants to be above the water. So we have to ensure that we can control this. The best way to control this is by altering the amount of volume will be submerged in the water in order to counteract the weight of the object, which is why boats kind of have this shape, so that they increase their surface area and volume submerged in the water to keep a boat that can be crazy heavy still afloat. Now, to further explain this phenomenon, let's consider a scuba diver. You have a scuba diver here. Her name is Jill. She's a happy scuba diver. She wants to go scuba diving. She's got her vest on, her tank, and everything. Again, my artistic skills are shining. Now, before she goes in the water, they're going to put weights in her vest to ensure that she can go down, she can sink. And in this case, they're going to increase her weight so that it is greater than the buoyancy force. So by doing that, we know that she's going to sink. She's only going to displace so much water, but her weight is going to be more than the weight of that water that she has displaced. Now, if she wants to come back up, say she's done for the day, she's ready to go back to the boat, we want the buoyancy force to be greater than the weight of Jill. Now, to do that, what most scuba divers do is they'll have certain bladders in their vest or in their wetsuit that will take in oxygen so that the volume of Jill increases, but not necessarily the weight. It's only adding a little bit of oxygen. It's not a lot of weight on the scale of a human, but it's essentially just going to add volume, which will displace more water than Jill initially had with her initial volume, which will then displace more mass of water, and since the amount of water displaced in weight is equal to the buoyancy force, we are going to raise the buoyancy force to ensure that it is more than her weight. Now, this is a very simple introduction to buoyancy. Thank you very much for watching. There's much more complicated things that go on with buoyancy, such as stability and many more concepts. Those are for other napkin topics, so be sure to watch the next video. Thank you.